Here we have a 0 to 1 inch outside micrometer. Go over the parts. We have the anvil, the frame, spindle, thimble, ratchet, lock. And if we have a little closer look, we can actually start to see the actual scale in which we're going to be using to actually measure it. Here we have a 0 to 1 outside micrometer. And we're now going to look at, as far as the measurements, how we use it. Okay, so if you notice that as I turn the thimble out, you can actually see the spindle coming back. And you can actually see the measurements. You see 1, 2, 3, 5 just got uncovered. And it'll go up to 10. 10 would represent 1 inch, or the maximum for this micrometer. You can see that this is divided, or the 1 inch is divided up into basically 10 individual divisions. And between each one of the numbers, between 7 and 8, we can actually see that there's actually three lines or 4 spaces between each one. Now if we go back to any one of the digits and start at 0 on the thimble, and we actually turn the micrometer 1 turn to the next 0, we'll actually see that 1 line has been exposed in between the 2 numbers. This would represent 25. So we have 1 divided into basically tenths, and each one of the tenths is divided up into 25, or 25 thou. Okay, so each turn is equal to 25. If you look on the actual thimble, you will see that it actually has 25 markings on it. So if we turn it another turn to 0 again, we see a second line show up. So we would be halfway, or 2 turns from one number to the next. Now if we're looking for a finer measurement, we can actually take it, and if we turn the micrometer a little bit, we actually see lines on the upper side of the 0 line. These lines now would be our 3rd digit that we would go. So if we were now going to use this and we were going to pick a number, we turn it in so far. Let's go to 7. So 7 and then 0, and we turn it slightly more than 25. So we would be 0.725 plus 2, and then we could actually turn it and see which one of those lines could line up to see how close we were to the next digit. And it looks like we're at 9. So the number would be 0.7279 would be our number. Okay, stop. So from the readings we took on the micrometer on our last video, if we were to record this on a piece of paper, we would write it down as this way. First of all, we would say that the first line was 0.7. Then we'd say that the thimble was turned once, so that would be 25 because 1 line was showing. Then we have 2 showing on the thimble, so we would write it down like this. And we'd also have 0.9 showing on the other side, so we would record it like this. We would then add these numbers up. So we would have 9, 7, 2, 7, 1. So this would be the size. 0.7279 would be the size of what we were measuring. Good value. I have a feeler gauge that's actually 0.29 thou, or 29 thou feeler gauge. and we're going to use it to actually, a micrometer, to actually measure it. Okay, so we're now going to spin the thimble with the ratchet. We're going to do that. One thing else we should be sure is that the lock is actually off and it's not causing any drag or restriction. We're going to turn the thimble in until we hear the ratchet click. That tells us that it's at the appropriate tension on the feeler gauge. If we actually used our finger to turn the thimble, we could actually over tighten the micrometer and get a different reading. So now that the ratchet is there, we're going to lock it, and then when we pull the feeler gauge out, there should be a little bit of tension to pull it out, so it shouldn't just fall out easy. And we're actually going to pick it up, and we should read, if we did our readings correctly, we should read 29. So there's their 0 line on our micrometer, and it is pointing to 4, so we know we've passed the 25 once. So 25 plus 4 would be 29, or 0.29 thou.